Folks, here we go. Day 71, Metal Resources. Today's purpose. I will learn what the most important metals are and where they are found. Relevance, our modern life depends on cheap supplies of these metals, and your success will be to locate main countries on the map. Now, on your quiz, which will be next week, Wednesday, there will be questions on, of the following metals, which are the most common? And I'll list some, and only one of them will be what's shown in this lesson. Like iron is the most common one. Or I might say, which of the following metals is not one of the top five? So in other words, you need to know the top five metals. And also I'm going to have questions of things like, let's say, iron is a common metal. It is found in Canada. Please locate Canada on the map. Or aluminum is found in India. Please locate India on the map. That kind of a thing. I am not going to ask you what metals are found in India. I am not going to ask you where is iron found. But I am going to say where are these countries. Alrighty. So, next quiz will be day 73, 74. That's after break here. Any questions on homework we've done so far? Main ideas, Isaiah, would you please read number one nice and loud?
Wind turbines make electricity when they're spinning, turning the generator at the top of the tower. They don't make pollution when they operate. They are not a dependable source of energy. They kill lots of birds.
So there are some drawbacks to wind turbines. Kylie, number two, and you'll stop halfway through that paragraph there because I have number three embedded there. So go ahead, Kylie, number two.
Solar panels make electricity when light makes electrons jump from one layer to another. They don't make pollution when they operate, but the making of them creates toxic chemicals. They're not a dependable source of energy.
So there are some drawbacks to solar power as well. They're not necessarily all clean. They involve toxic chemicals you have to dispose of at the end of making them, and they don't make electricity all the time, obviously not at night. Number three. Let's see here. Stephanie, number three.
Hydroelectric dams make electricity when water rushing through them turns the generator. They don't make pollution when they operate, but CO2 is made by rotting materials in the reservoirs. Filling them destroys the land environment in a valley and replaces it with a lake environment. Not many places can have a dam.
You can't build a dam any old place. You can't build them in Illinois very well. Because if you make a dam across a river, it's so flat around here, the river will just flow right around the dam. You have to have a river in a deep valley so that you block off the bottom of the valley, then you fill the valley up with water. And unfortunately, most of the places where we could build a dam for lots of energy, we already have. Another thing about the hydroelectric is that it does produce CO2 by having rotting materials in the reservoirs, and it kills off the environment in that spot. Number four, Chiara, would you please read that?
Nuclear power plants are a green energy source because they do not release any pollution in their operation. They do have radioactive waste that needs to be carefully handled. The uranium fuel rods get very hot when they are placed close together. The heat is used to boil water. The steam turns to a generator.
Okay, so nuclear power has its problems as well with the radioactive waste. But it is the biggest source of energy that we can make that does not produce any CO2. Okay, next page. This is a edited version of a newspaper article that I saw in the local paper about Libertyville. Let's read through it quickly here. The Libertyville Elementary School District 70 will take a slice out of its electric bills in the months ahead now that the largest two of its five schools are topped with solar panels. The $3.2 million solar power project at Butterfield School and Highland Middle School was recently completed, with each school hosting about 1,800 solar panels on the flat school building roofs. The panels are expected to produce about 30% of the electrical power needed to run each school. The project makes District 70 the largest school district in Illinois to run by solar power, and it could be one of the largest solar power school districts in the Midwest, officials said. The new energy source is expected to save the district up to $5,000 a month on electric bills. They are expected to last 30 years. The project was possible through a private energy gift of $1.8 million from the Illinois Clean Energy Community Foundation. Okay, so it's great that the school has done this. Fantastic. I love it, and I'm not being sarcastic at all. It's good on many different levels. But let's look at the finances of this. How much do they save in the school each year? It says, let's see here, where is it? $5,000 a month for 12 months. So you have to multiply 5,000 times 12, and you get $60,000 a year. Woohoo! That's good. I'm glad they're doing that. Now, they're expected to last 30 years. So how much will they save over the whole lifespan of these things before we throw them away as junk? So you multiply $60,000 per year times 30 years, you get $1,800,000. Woohoo! Great, good, I love it. I'm glad that the school is doing that, and I'm not being sarcastic at all. However, how much did it cost them to save $1,800,000? $3.2 million. Did they gain or lose money in the deal? Okay, just on those numbers, they lost money. But obviously the school's not going to do something that stupid. They got somebody to cover the extra cost, and it was here, this Illinois Clean Energy Community Foundation. So there's a charity that raises money from businesses and rich folks. They collect all this money and then they give it to schools for solar projects. Okay, great on them. I'm glad that there's a good institution like that. However, here's my point. Would it make sense for us to buy solar panels for our house? Well, unless you get somebody to give you a bunch of money, you're going to lose on that prospect. Solar power just isn't up to the development that it needs to take over our economy. Alrighty?
Yeah.
Turn the page, please. We're on page 57 right now. In the last class I skipped these, so I crossed them off, but let's do them here in this class. Which type of energy source had the biggest increase between 2000 and 2013? So we have all these 5 types of renewable energies, and we have the years going down the line there. Which type had the biggest increase? Look at those. Victoria, which one do you think had the biggest increase? Wind. Yep, it started off at 0.1% and it ended up at 4%. That's the biggest increase. Wind. Which of the following types of energy sources had the biggest decrease between 2000 and 2013? Natalie? Okay. Bryce, what do you think?
Hydropower.
Hydropower started off at 7.2% and then it was only 6%. So there's a couple possibilities there. Maybe a couple dams broke down and they abandoned them. Or maybe they kept producing the exact same amount, but we've made lots of other kinds of power. So percentage-wise, that much of hydroelectric is a smaller portion of the total, even though the actual amount is the same. Okay, which of the following kept most steady? And that is going to be geothermal. It starts off at 0.4 and it ends at 0.4, and all the way in between it's 0.4, 0.4, 0.4. So the geothermal kept most consistent. Okay, we're going to do the next couple pages, questions, in a style of notes. So I'm just going to read through them and review our stuff.
Okay, I like that.
Photovoltaic panels work by sunlight hitting electrons. The energy of all the photons of light make the electrons able to jump across a little gap and make a current. So we use that current to light up our houses and such. Generators. We saw generators yesterday in our little lab activity. We were passing magnets by wires, and the magnetic fields push the electrons in the wires to make the current. So letter A. Whoop, that's not right. They don't heat them up. It should be B. Sorry about that. How do wind turbines work? The turning blades turn the gears, spin the generator. They're moving the magnets next to the wires, spinning magnets next to wires, so that you make the current. Hydroelectric plants do the exact same thing as a wind turbine, only instead of wind blowing, it's water rushing through the dam, pushing on the turbines.
Wait, what's number 10?
Number 10 is B. Number 11, uranium with nuclear power plants is just a fancy way of boiling water. A very expensive way of boiling water, but you can boil a lot of it. Uranium atoms naturally break apart in the fuel rods and release heat. The heat boils water. The steam from the boiling water rushes through pipes, rushes through these fancy turbine blades, making them spin like a fan, and that spins the generator. Number 12 and 13, I guess, should be switched around. Maybe I'll do that for next year. What are the drawbacks of wind and solar power? They don't go all the time. In order to run a very complicated economy, you have to have electricity 100% of the time. Wind and sun don't work 100% of the time. So you need these backup power plants. And the backup power plants are natural gas powered plants that can be turned on and off really quickly. The problem with that is if you're just simply looking at reducing CO2, this is not the way to do it. Because the turning on and off of the natural gas plants is very inefficient and dirty. They're not warmed up, so they don't run efficiently. So they actually produce more carbon dioxide if you just simply let them run all the time and just be a regular power plant. Number 14, photovoltaic systems require batteries. That's bad because of the toxic chemicals. You really should not be throwing away batteries in the regular old garbage. You should have them go to a recycling center. So what I'm trying to get at here is every single style of making energy has some kind of drawback. There are no perfect solutions. Number 15, problem with nuclear is the waste, of course. Problem with wind power, kills lots of birds and only works on windy days. Hydroelectric plants are not great because they flood areas, so little butterflies and squirrels can't live there no more. Green energy. Okay, nuclear is considered green because it does not produce pollution just randomly. Yes, it has the bad waste, but we can hold on to that, put it in barrels, and contain it. It does not produce CO2. Hydroelectric, there is some CO2 made by the rotting of the vegetation at the bottom, but not a whole lot. These are the two things that can make lots and lots of electricity without lots and lots of pollution. Solar and wind, they just don't quite make it economically. Drawbacks of photovoltaics is that we need to use toxic chemicals to make them and require sunny days, require lots of space. Only 2 accidents by nuclear power plants over the last 50 years. Some people say, hey, that's pretty good odds, let's keep on doing it. Other people say, no, that's too many. It depends upon your own personal desires, your own personal values, your own personal feeling of safety. It's not a scientific issue. That's something to debate about at the ballot box. We're going to do, we've already done that lab, so we don't have to worry about that. We did it yesterday.
Oh, I didn't do it. Just do it again. Back.
Next, number 1 of our new notes, metal resources. 5 most commonly used metals. You need to know what these 5 are. Iron, the most used metal on the planet. Main ingredient in alloy is called steel. And let's see where those are located. They are made, it's dug mostly in Australia, Brazil, China, and India. So please put an A down here for Australia. Please put a B over here for Brazil. Put a C over here for China. And I for India. The R on top is Russia. That's for the aluminum thing. On your quiz, though, I'm going to have this exact same map. I'm going to have these areas circled and some other areas circled. And I'm just going to say which region is Russia in. What region is Brazil in? And you're just going to say the circle, okay? You don't You don't have to know the exact location. Aluminum is the second most common metal, and it's good because it's lightweight, so you can make airplanes out of it really well. Cars need to be as light as possible, so they make cars with that a lot. China, Russia, Canada, India. Canada's up here. Russia's over there. China and India. Questions there? The third most. Anybody have a guess as to what we make pipes out of and the electrical wires out of a lot of? Starts with a C. Copper. Third most common metal. So it is found in Chile, China, Peru, Congo, and the USA. Chile is on the left side of South America. Peru is right above it. Congo, I believe they consider that Central Africa, maybe South, it doesn't really matter. It's about there. Again, you don't need to know the exact place, you just need to know it's somewhere in Africa. China, over there again. Okay, next, zinc. Zinc is the fourth most common metal. You may have seen some metal pieces at Menards or Home Depot that are gray, but they're kind of powdery gray. It's powdery because it's covered in zinc. It helps to reduce rust. So that's found in Sweden. Sweden is up here. Whoop. There's Sweden. Kazakhstan is right there. It used to be part of the Soviet Union. It's now its own independent country. Bolivia is by Brazil. I hope you all know where Mexico, USA are. Australia, over there again. India, we've labeled before. Peru and China. China does have an awful lot of resources. Big country. Next page. Nickel, the fifth most common metal. Part of stainless steel. Stainless steel is made out of iron and many other things, but it's mostly iron. The nickel helps to have its special properties. It's found in places like the Philippines over here. Indonesia is a bunch of islands. Canada up here again. Australia. Russia up on top. Brazil again. Guatemala is just south of Mexico. And Cuba is the island south of Florida. And lastly, it's not one of the more common metals, but it's important for finances, for obvious reasons, gold. It is used in electronics because it does conduct electricity very, very well. So, see here, Uzbekistan is by Kazakhstan. Indonesia, we talked about before. Ghana is in Africa. Canada and Peru, we've talked about before. South Africa truly is the southernmost part of Africa. Next page. Just like gold, lithium is not one of the dominant metals, but it is getting to be more and more important with batteries. And so we see that in Argentina, Chile right next door, Australia, China, and Zimbabwe is generally in the same area as Congo, generally. Again, for your quiz, I'm not going to ask you where is lithium found. Or I'm not going to ask you what country, where's lithium found, or what is found in Zimbabwe. But I'm going to say lithium is found in Zimbabwe. Find Zimbabwe on the map. That kind of thing. Okay. That is the end of that.